definite. So we're going to look at a few different cases with our discriminants, and we're also going to be looking at not just the discriminant but the coefficient of x squared, in other words a. So we can say that the expression ax squared plus bx plus c is positive definite if it is positive for all real values of x. So for example, every single value of x on this example here has a positive y value. So we could say that this is a positive definite. Now, looking at this though, the parabola, what do we see? For it to be positive definite, it must be concave up, concave up. For it to be concave up, can anybody tell me what are the conditions for a parabola to be concave up, looking at the equation?
The coefficient of the x squared has to be positive.
So in other words, absolutely, a has got to be greater than 0. Okay, so we know that it's concave up, a is greater than 0. What else do we know? It mustn't, for it to be all positive, it must not touch or cut the x-axis. So the other point here, the parabola must not touch or cut the x-axis. And when these two things are the case, we say that this quadratic expression is positive definite. Got your book there? Thank you. Okay. This summarises it nicely. So the expression is positive definite if a is greater than 0 and for it not to touch or cut the x-axis, what can we say about the discriminant? What must the discriminant be?
Greater than.
Are you sure if it's greater than? It has roots. We want it not to cut. Yes, and also the discriminant must be
less than 0.
Less than 0. So there are two situations. So if nothing else, I encourage you to just write positive definite if a is greater than 0 and the discriminant is less than 0. In other words, it doesn't touch or cut the x-axis anywhere. Okay, alternatively, if the quadratic expression has a minimum value which is greater than 0, so you could prove that something is positive definite by finding the minimum value and showing that it is greater than 0, and hence the whole quadratic expression is greater than 0. It's positive definite. Okay. Well, it's going to be very similar for negative definite. Very, very similar. Let me just scroll down a bit so we can have a look at our examples here. So case 2. Case 2, we see that it is negative, or the y values are negative for every part of this parabola. And so, for that to happen, two things must happen. We see that this has to be concave down. Concave down. For it to be concave down, what are the conditions in the quadratic expression that tell us that it's concave down? Negative coefficient of x squared, so in other words, a has to be less than 0. And also, the parabola must not touch or cut the x-axis. So much like with the positive definite, must not touch or cut the x-axis. And when does it not touch or cut the x-axis? What do we know about the discriminant in this case? The discriminant is 0, because 0 means that there are no roots, or no real root, which means that it doesn't cut the x-axis, because those roots are where it cuts the axis. So we could say that it's negative definite if a is less than 0 and the discriminant is also less than 0. So positive definite, a was greater than 0, discriminant was less than 0. Negative definite is a is less than 0 and the discriminant is less than 0. But we've only looked at 2 cases so far. By the way, this just shows you an alternative way. So if you had a question, another way you could do it is to find the maximum value. Find that the maximum value is less than 0 and hence all the values are less than 0. But that is only 2 cases. Let's look at the third case. The third case is indefinite. Indefinite means that it is positive for some values of x, negative for others. Doesn't matter whether a is positive or negative in this case. No. So it could be concave up or concave down. But what do we know about the discriminant in this case?
It's going to
be greater than 0 because it's going to have roots. It's going to have those roots. Okay, so in order for this to happen, it must cut, the parabola must cut the x-axis, and this happens when the discriminant is greater than 0. So hence the expression is indefinite if the discriminant is greater than 0. There is one final case that we will look at. Can anyone think of the one situation we've not covered yet? We've looked at when it's all positive, we've looked at when it's all negative. All above, all below, we've looked at when it cuts twice.
What's the discriminant for negative, the case 2?
Oh, the discriminant is less than 0.
Ask the same.
Yes, yes. So it's positive definite, so we could just make a little note of that. So it's positive definite. We have a is greater than 0 and the discriminant is less than 0. Then we have negative definite. On negative definite, a is less than 0 and the discriminant is less than 0. Then you have indefinite. And for indefinite, the discriminant is just greater than 0. A doesn't matter what a is.
What about when the discriminant equals?
That's the case 4. Case 4. And this is when the discriminant equals 0. And that means it's 0 for one value of x. And other than that, it's negative for all values if a is greater than 0. Or it's negative for all other values if that coefficient of x squared is less than 0. Okay? So there are 4 cases. There is a summary box right there. So that's on your notes as well. So that would be a great thing just to keep in mind. We're going to now have a look at these questions, and we're just going to work through these 4 questions here today. We're going to decide if they are positive definite, negative definite, or neither. Okay, so for question 1A. 1A. Well, the first thing we're going to look at is A. What can we know about A? Is A greater than or less than 0? A is greater than 0, so we can say A is greater than 0. Also, what about the discriminant? Well, we better find out what the discriminant is. We don't know yet. We'll have to find it out. So discriminant equals b squared minus 4ac. Let's sub in our values. B is, of course, negative 5 squared minus 4 times A is 3, C is 1. So we have 25 minus 12, which is 13. What do you reckon? What is it? The discriminant is what?
Indefinite.
The discriminant happens to be greater than 0. So for it to be greater than 0, this is indefinite. The three options on the question were positive definite, negative definite, or neither. So we're just going to say neither, but yes, indefinite. So therefore, it is neither. Do you need this over here anymore? You've got it written down? Great, I'll rub that off so we can fit 2 on at a time. B. Well, what do we notice about A? Is A greater than or less than 0? A is greater than 0. Also, now let's look at the discriminant. The discriminant equals B squared minus 4AC. B squared. Well, notice that this is out of order in this one. Do you notice that?
Yeah.
So let's just take a moment to write down what they are. A equals, well, A is the coefficient of x squared, which is 1. B is the coefficient of x, and what's B in this case?
1.
Negative 1, thank you. C is the constant term, which in this case is 7. So now let's come over here. We have minus 1 squared minus 4 times A is 1 and C is 7. So you have 1 minus 28, which equals minus 27, which is less than 0. So the discriminant is less than 0 and A is greater than 0. What does that mean? Positive definite. Because the discriminant is less than 0, it doesn't cut the x-axis anywhere. A is greater than 0, it's concave up. So it is positive definite. Positive definite. C. So for C we have, notice we're out of order again. So be careful with these questions. Don't just take the first number and say that's A. It's not. In this case, A is negative 1, B is 3, and C equals negative 4. Make sure you include the right signs as well. So, what can we say about A? It's less than 0 this time. Also, we better check out the discriminant. Discriminant equals B squared minus 4AC. B is 3, so we have 3 squared minus 4 times A, which is minus 1, times C, which is minus 4. Well, 3 squared is 9. We have 3 negatives multiplied together. What will that give? A positive or a negative answer? Negative. Will be negative 16. So we have the discriminant is less than 0. So if A is less than 0, so it's concave down, discriminant is less than 0, doesn't cut the x-axis. What can we say about this quadratic expression? It's negative definite. It's always going to be negative. one's an interesting question. It says find the value of k, which will make kx squared minus 2x plus k negative definite. So let's just remind ourselves of what's required for a negative definite. Negative definite means that we have what? What must A be?
Negative.
A must be negative. A must be less than 0, and the discriminant must be
Negative.
negative as well. You cannot cut the x-axis. Okay?
2 squared.
So that being the case, for A to be less than 0, therefore we must have K must be less than 0.
2 negative.
Are we okay with that? Because we just said that A must be less than 0. In this case, A equals K, because K is the coefficient of x squared, so hence K must be less than 0. Is that clear? But have we proved everything yet? Well, we've only found when half of it works. Let's find when the discriminant is less than 0 as well. So we also need the discriminant. B squared minus 4AC. Well, B in this case is negative 2. Okay. And minus 4 times by A is K. And C is K. So we have 4 minus 4K. 4 minus 4K. Squared, thank you. What's the K squared? Tell me, what do we want the discriminant to be? Less than 0. So in other words, we are needing to have 4 minus 4K squared to be less than 0. Okay, well, we can factor out the 4. We have 1 minus K squared. 1 minus K squared is less than 0. Do you see how that is the difference of 2 squares? Oh, well, let's factor that out. 1 plus K. 1 minus K is less than 0. So what are the points? 1 and negative 1, because when will this be 0? So let's just draw this a moment. 1 and negative 1. 1 and negative 1 has got to be the points where that would be equal to 0. Now, we're already saying that K is less than 0. K is less than 0, it's going to be concave down, upside down problem. So it's going to be something like that, right? So which values is that less than 1? Sorry, not less than 1. I just told you the answer. What values is it less than 0? It's going to be less than 0 when K is either, K has to be less than negative 1 or K is greater than 1. But now we've got to put that together. For the first case, we said K had to be less than 0. Then for the next one, we say that K has to be less than negative 1 or K is greater than 1. What situation, if we were to combine all those results, what would we have to say K is to work for everything? K would have to be less than negative 1. Okay? That would work for this, and it would work for this part. So combining results, K is less than negative 1. Any questions about that one? No, not sure. Your brain's a bit tired. Well, at least it is recorded so you can go back and watch it when your brain is feeling a bit more fresh. But basically, this part is discounted. We can't include that because we already said at the beginning that it has to be less than 0. So the only case when it's less than 0 has to be, well, when it is less than -1, because it cannot be between -1 and 0, because in this area here, even though it's part of this, it would fail the second part of the test. There are 2 tests for it to be negative definite. A has to be less than 0 and the discriminant has to be less than 0. You have a question, Mills?
Yeah. I think the camera.
Oh, sorry.
Not sure if it's still recording, is it?
So everyone.
Low battery.
Oh, no.
Is it still recording?
Yeah, it is.
Well, your battery is going to die.
Maybe not fall off, but hopefully it will last. Okay.
If your battery dies, will it save it?
Yeah, mine does save it.
How much battery does it have?
I don't know.
629.
Let me just...
Just take the cord out and plug it in the computer.
I can do that.
Wait, it's not even focused. Or is that just because I don't mind?
Plug it in the computer.
Oh, yeah.
Next question up.
I can do that. Except I don't have the cord even for that.
So you just pull the cord out of the.
It's connected.
No. And it's not going to reach all the way.
Got an extension cord?
No. I'll just focus on just the part that needs to be. Okay, that you'll still be able to see everything there.
Miss, why does combining results give K as less than -1?
Yeah, good question. I'll come back to that.
That's because you've got a, in the question it wants the negative definite. So you just, yeah, you can't
Oh, I
have
know. So what does combining results mean?
So basically, it means we're combining this result that K has to be less than 1, and we're combining the result that K also has to be less than -1. So for it to be less than 0 and less than -1, the only time that works for both is when K is less than -1. Yeah? So it's like we're putting in all these requirements. So just say Zali can't do, you're trying to organise an event, Zali can only do Monday, Tuesday, Wednesday, and Olivia can only do Tuesday and Thursday. If we combine the results, we say it has to be Wednesday. It has to be what's common. Okay? Did I say that wrong?
Yeah.
Well, I think you get what I mean. So for something, it has to be what works for both of them. Yeah. So the only time that it works for both is when it's less than -1. That keeps everyone happy. Okay, question 3. So this time we want to show that this big long thing here is positive definite. If that is positive definite, then K is greater than 3. So let's just write first, and I encourage you in a test situation to do this at the start, because even if you don't get the question finished or you don't get it all correct, you're at least showing some understanding here by writing what positive definite is, and you could get some marks here because you're showing that you know what you're talking about. So for it to be positive definite, what does A have to be?
Greater than.
It's got to be greater than, it's got to be concave up. And what do we know about the discriminant?
It has to be
Less than, because it cannot cut the x-axis. So we know that these two things have to be the case. So for A to be greater than 0, A is the coefficient of x squared, so hence K minus 1 has to be greater than 0, or K has to be greater than 1. Are we okay with that so far? Because our A is K minus 1. Okay, so we already know that K has to be greater than 1. Now we've got to look at the second part of the question, we have to now find when is the discriminant less than 0. When is the discriminant less than 0? Well, we also know that then b squared minus 4ac has to be less than 0. B in this case is k plus 1 squared minus 4. A is k minus 1. C is also k minus 1. Has to be less than 0. We've got a little bit of algebra to do here. Well, let's expand out these brackets here. We have k squared plus 2k plus 1 minus 4. And here we have k squared minus 2k plus 1 less than 0. Now expand our second lot of brackets. K squared plus 2k plus 1 minus 4k squared plus 8k minus 4 is less than 0. What could we do now to make it simpler for us? Can we collect like terms? Yes, I see like terms here. Let's put all the k squares together. We have 1 minus 4, so we have negative 3k squared. Let's look at the k's. How many k's do we have? Well, we have 2k plus another 8k, which is a total of 10k. And then you have a 1 minus 4 is minus 3. In the interest of time, because we do not have a heap of time of class left, and I would like to finish off question 4. I will give you what the factorisation is. It turns out to be 3k minus 1 and then k minus 3. I just factorised the quadratic from before.
Are we going to have to be able to do that ourselves?
Are you going to have to be able to do it yourselves? Yes. Do you want me to take the time to show you how to do that?
Is that? No, that's right.
Here, I think you would. It won't take me long. I'll just factorise it for you over here. So, just a little aside here. So, we'll continue this working in a moment. But negative 3k squared plus 10, that went to be 10k, sorry about that, put a k there. Minus 3 is less than 0. Okay. I can divide everything by negative 1. If I divide everything by negative 1, I have 3k squared minus 10k plus 3 is greater than 0, which is what as I quickly just wrote down the answer, I didn't change that for you. So it's greater than 0. So now if we think about our factorisation here, 3 times 3 is 9. So we want two numbers that multiply to 9 adds to minus 10, and those two numbers would be negative 9 and negative 1. So 3k squared minus 9k minus k plus 3. I just broke that apart because I tried to find the two numbers that multiply to give 9, add to give negative 10. Remember that, I think some of you, depending on what classes you're in, they're all... Do it your one, yes.
Wait, what's the other way? What's the other way again?
But that would make sense because basically like you're flipping it to the other side.
Yeah.
And then-
Whenever you multiply divide by negative number, the sign switches on and then you call it.
Yeah, that makes sense.
Yeah?
Yeah.
Yeah, because basically you're bringing that to all that equation to the other side.
Yep.
So it's as if the 0 was on the negative side.
Yeah, so true.
And then
And then this way is 3k minus 1, k minus 3 is greater than 0. So that's how you do it. There are multiple ways of how to factorise non-monic quadratics. If you don't like my way, go back and check your way, revise your way of doing it. That's my way. How do I get negative 9 and negative 1?
You just put your face.
That's the numbers from here.
Yeah. So you just do it your way. Okay.
Oh, it's 30 and
Yeah.
no. Yes.
This question says show k is greater than like.
Okay, yeah, we're getting there, we're getting there. So look here, we are so close to being finished. In order for this to be greater, in order for this to be greater than 0, two things have to be the case. Both of these numbers must be greater than 0. So in other words, 3k minus 1 has to be greater than 0. And k minus 3 has to be greater than 0. Well, add 1 to both sides, 3k is greater than 1, or k is greater than a third. Over here, we just add 1 to both sides. It's not 1, add 3 to both sides, because it's minus 3, add 3 to compensate to both sides. So I have 3 conditions here. I'm going to circle them in a different colour because we have just shown 3 conditions. We've shown that k is going to be greater than 1, k is going to be greater than a third, and k has to be greater than 3. So when does it keep everybody happy? A greater than 3 is when we put all of that together, and we've just shown it. So putting this together, or combining results is probably an even better way to say it. Combining results, k has to be greater than 3. And we've just shown what we were asked to show. Are we okay with that?
Yep. Makes sense.
Another way to think of it with these inequalities. I have helped my mum out. My mum does catering for large events sometimes. When she does catering, I like to help her at times. And you know, people have all these different dietary requirements. You've got to try and keep everybody happy. So instead of having separate meals, sometimes for the gluten-free, separate for the people who can't have beans, separate for the people who are vegan, sometimes what we'll do is try and find a menu that actually everybody is going to be happy with. So you take out all the things that, you keep out all the things that certain people can't eat. Then you just have to cook one batch. Oh, it can be amazing. Everybody can enjoy it because it's within what everybody is happy to eat. But it keeps everybody happy. So here you've got to find values that would keep everybody happy here, and that is when k is greater than 3. Question 4. Okay, let's give this one a go. See if we can get it out before the bell goes. For what values of k is this expression, negative definite? Can somebody see what's the problem here?
There's no square.
Okay, it's not written out well for us. There will be an x squared though if we were to expand the brackets. So the first step here would to be expand the brackets. But even before we expand the brackets, we want it negative definite. So let's just give the definition. Negative definite occurs when a is less than 0 and the discriminant is less than 0. Well, let's expand out all these brackets. So we have k, x plus 1 and x minus 8 minus x plus 4. Okay, so I'm going to expand out these two brackets first. X times x is x squared. X times negative 8, negative 8x. 1 times x is plus x there, and 1 times negative 8 is negative 8. Now I'll just expand out the negative here as well, and we have a negative x, negative 4. My next step would be to expand out the k's. So multiply everything inside the brackets by k. So I have k x squared minus 8kx plus kx minus 8k minus x minus 4. The next thing that will help me is if I could collect all of coefficients of x squared together, the coefficients of x together, and the other terms. So I have kx squared. I have minus 8kx plus kx. So minus 8 plus minus 7kx plus we have another one here. So there's 3 x terms here. So we have minus 7 minus 1. Okay? Minus 7 minus 1. Minus 7k and then a minus 1 here.
What is it? One is just an x and then 1k and the other two are kx?
Sorry, so this part here, these two are kx, yes?
Yes.
Yeah.
Okay? So we have here minus 7kx
Yes.
minus x. I'll do it in 2 steps so it's less confusing. Minus 8k minus 4. So if I was to now put this together in 1, I could have minus 7k plus 1x minus 8k minus 4. Are you okay with that? So what I did is I just collected these two together and put it in brackets, just collected or factorised my x's so I could get a nice clear b. I want a b all together. Okay? Now I know that for it to be negative definite, the first thing I notice is, or the coefficient of x squared is k,